Welcome to ClickMyProject.com. Now we are going to discuss about classification and prediction of a significant cyber incident using data mining and machine learning algorithm. Now let's see the abstract of this project. Cyber incidents are becoming increasingly common and sophisticated. Significant cyber incident can have a major impact on organization both financially and reputationally. This makes it more robust to noise. So there is a need for effective methods to classify and predict SCIs. Traditional machine learning methods such as support vector machine and decision tree can be difficult to train and tune, and they may not be able to handle the complexity of SCI data. Random forest is a machine learning algorithm that can be used to classify and predict SCIs. Random forest is an ensemble learning algorithm that builds multiple and outlier than traditional machine learning algorithm. So here we are going to use a random forest and naive-Bayes algorithm for the prediction. The result showed that random forest had the best performance in terms of accuracy. Now let's see the flow diagram of this project. Initially, in the starting, we are going to load and select a data set. The websites used to collect a data set is such as a Kaggle, UCI and GitHub repositories. So now we have selected the data and we are going to pre-process the data. The pre-processing is nothing but replacing the missing values, which means irrelevant values or null values with 0 or mean values. After cleaning the data set, we are going to split that original data set to pre-pandemic and post-pandemic data set, which means we are going to split the data set according to the year, like before 2020 is considered as the pre-pandemic, and after the data is a post-pandemic data set. And after the successful splitting, we are going to split train and test for both the pre and post pandemic datasets. So here we are going to classify using a random forest and naive-Bayes algorithm. We will classify the train data and we will predict using the test data. After the successful prediction, we can view the performance analysis and report also. Performance analysis in the sense accuracy, and also we are going to compare both the pre-pandemic and post-pandemic data set, and we are going to display the or visualize using a bar plot. Now let's see how to run the project. So initially these are the data in the data set we have selected. After that we are going to pre-process the data. This means checking a missing value. So there is a missing value in the continent column. So we have replaced that missing value with a 0 here. After that as we said, we are going to split the data set into a pre-pandemic data set and post-pandemic data set. So these are the data, like there are 498 rows in the pre-pandemic data set, and in post-pandemic data set there are 449 rows. So after that we are going to do a label encoding because we need to convert the string values into int values, so that we can easily predict the values. So here we have splitted the pre-pandemic data set into train, X train and Y train. Like these are the data need to be predicted and these are the labels. So now we have classified the data using a random forest. The accuracy produced by the random forest algorithm is 96 in the pre-pandemic dataset, and using a naive-Bayes classifier, the 96% in the accuracy score. So after that we are going to encode label encoding in the post-pandemic dataset. The same procedure will be followed for the post-pandemic dataset also. So we have label encoding. The EDA is for the pre-pandemic dataset, and so we have splitted the post-pandemic data set. These are the values, and Now we have classify using a random forest algorithm. The accuracy is 98.88, and using a naive Bayes algorithm it gives 100% accuracy. So the comparison for the random forest algorithm in the post and the naive Bayes algorithm, the post pandemic, is nearly same. So a prediction made by the classifier is a 0-day exploit attack. So this prediction is done using any one of the rows from the test data.